Nice to meet you, Dr. Wu. This time in this project, I focused on the simulation and analysis of social networks. This topic is relatively new nowadays, and it's part of network science area. In recent years, more and more scholars are attracted to do research on this topic. In real life, everyone has their own interpersonal relationship networks. These networks as a whole construct the social networks. Within the social network, people can be denoted as the node, and the relationship among people can be denoted as the link. This can be illustrated as this figure. If social networks can be looked like a whole system, the main part is the user. Users can make a choice whether to release their personal information. Besides, users can also set up and maintain the relationships among them and other people inside the social networks, as well as share some information such as pictures and blogs. Moreover, users can also browse and evaluate messages and information shared by friends. These are main characteristics of social network. In 1967, Professor Stan Lee put forward 6 degrees of separation theory, which is deemed as the foundation of social networks. It can be described as this figure. According to this theory, everyone's interpersonal relations become bigger and bigger within the networks. Finally, it consists the entire social network. It can be simply specified that the distance between someone and anyone else in this world is less than 6, which means that someone can know anybody else through at most 6 different people. Social networks can be classified for 3 types. The first one is network of friends. This kind of social networks can be recognized as the mapping of interpersonal relationships in real world. Many famous social network websites belong to this sort, such as Facebook and LinkedIn. The second one is website for blogs. Blog web networks are mainly vector networks, meaning that user A can pay attention to user B. However, user B might not pay attention to user A in comparison. Some famous blog websites are like Google Bloggers and Microsoft Live Spaces. The third one is instant communication social networks. Every user inside this system has their own contact friend list. They can construct their own networks based on the friend relationships inside the instant systems, such as MSN and Skype. However, the services and functions of all the social networks mentioned above might have some overlapping and complementation. For example, Facebook allows users to propagate their own microblogs. So this makes us difficult to separate social networks distinctly and clearly. The main methods researchers use to discuss social networks are independent cascade model and a shortest path model. I implemented my project using the second choice. These methods can greatly decrease the calculation amount to get merit data. Here are some demos for my program. I will show this part using my program. In this project, I analyzed the social network using MATLAB. it can be separated into two parts. First, I define the main function, which is describe the topology of social networks, including nodes, which represents individuals, and links between nodes, which represents relationships. We can define and change the total number of people inside the networks, which is here, as well as we can choose our own spot number, which is here. I can use this code looking for anyone else inside the network if I want. The links among nodes are randomly attributed. This information is defined between row 7 and row 20. From row 24 to row 34, I define the links between nodes. If distance is less than a certain number, the link won't be set up. From row 36 to row 46, this part is used to prevent node which doesn't have links connecting to them, because anyone should have a relationship with others. This is basically based on the reality meaning. From row 49 to row 60, I define the cost of links. In order to specify more clearly, I define the links as 1. From row 63 to row 82, I draw the topology based on those information mentioned above. From row 88 to the end, I implemented the shortest path model among nodes, which is one of the two major methods used in social network analysis. This theory is based on the topic of information propagation analysis mentioned in my report. Besides, then I define another function called pathplot to call the parameters and algorithms defined in main function, showed up just now. And I draw the path and mark it in red finally. I will show the process here. First, suppose the total number of people inside the topology is 80. And my spot number is, let's say, just 20. And first, I draw the topology. Which is here. Then, for example, suppose I want to find the person whose spot number is 40. So I call the pathplot function here. The number is 40, we suppose. So we can get the path from here to here. The spot marked as star is what I sit, and the circle is the person whom I'm looking for. So I need to pass 1, 2, 3, 4, 5. There are 4 persons in the middle, and these informations are their coordinates. Maybe I can see like this. And let's try another one. So Let's try a bigger one. Suppose the total number of people inside the network is 150. Because if it's too big, then the topology is hard to see. Then suppose my spot number is 90, for example. Then I also draw the topology first. The figure is like this. It's much more tense than just one. So this spot marked in star is what I set. Then suppose I'm looking for the person whose spot number is 115. So I called pathplot function and write the spot number I'm looking for, 115. Then here's the path. This is me. This is the one I'm looking for. So 1, 2, 3, 4, 5 only. Also the 5. If you want to find the guys inside other parts of the network, it can be done. And these are the persons in the middle, their information. This is the demo for my project. Thank you for watching.